Matter feels fundamental. You touch it, you see it, you measure it. Everything you interact with appears solid, tangible, made of stuff. From childhood, reality seems built out of particles moving through space, colliding, combining, breaking apart. Information, by contrast, feels abstract. Numbers, symbols, bits, something secondary. Something we invented to describe the world, not something the world itself is made of. But physics has been quietly reversing that assumption, and the reversal is unsettling. Matter may not be the foundation of reality at all. Information may be. The idea sounds modern, almost digital, but it did not come from computers. It came from physics running into its own limits. Again and again, when physicists pushed deeper, matter dissolved into something less tangible. Atoms were once thought to be solid building blocks. Then they became mostly empty space. Protons and neutrons dissolved into quarks. Quarks became excitations of fields. Fields became mathematical objects defined by relationships, not substance. At every step, the stuff faded, and the structure remained. What persisted was not matter, but the information describing how systems can behave. This shift became impossible to ignore when physics encountered black holes. Black holes are not just extreme objects, they are stress tests for reality. Drop matter into a black hole, and something strange happens. From the outside, the matter never quite crosses the horizon. Its information appears to smear across the surface. From the inside, according to classical relativity, the information is lost forever at the singularity. Two theories, two answers. One says information is preserved, the other says it is destroyed. Physics cannot accept both. Information loss breaks the rules of quantum mechanics. But preserving information seems to require that black holes store it somehow. This is where the concept of information stopped being a bookkeeping tool and became a physical entity. If information cannot be destroyed, then it must be real, not metaphorically, physically. This realization forced a radical rethinking. Black holes behave as if all the information about what falls inside is encoded on their surface, not inside the volume, but on the boundary. This led to the holographic principle, the idea that the information content of a region of space is proportional not to its volume, but to its surface area. In other words, the universe may be like a hologram. The three-dimensional world you experience could be a projection of information encoded on a lower dimensional boundary. This is not science fiction. It emerges from attempts to reconcile gravity and quantum mechanics. And once you take it seriously, matter becomes secondary. What matters is how much information a system can store and how that information evolves. Consider entropy. Entropy is often described as disorder, but that is a shortcut. At its core, entropy measures information. It tells you how many microscopic configurations correspond to the same macroscopic appearance. When entropy increases, information about the exact state is lost to you, even if it is preserved globally. The arrow of time itself is tied to information flow. Time feels like it moves forward because information spreads, correlations decay, and the past becomes harder to reconstruct. The universe remembers less about its exact microstate as time passes. That forgetting is what you experience as temporal direction. Again, information sits at the center. Quantum mechanics deepens this further. In quantum theory, particles do not have definite properties until measured. What exists prior to measurement is not a thing, but a set of probabilities, a catalog of possible outcomes. Information about what could happen, not what is. When a measurement occurs, information is updated. The wave function collapses or decoheres, depending on interpretation. Either way, reality does not consist of particles with fixed attributes. It consists of information being processed. Interactions are not collisions of solid objects. They are exchanges of information that constrain future possibilities. Even entanglement, one of the strangest features of quantum physics, is best understood informationally. Two particles can share information in such a way that their states are correlated no matter how far apart they are. Distance becomes irrelevant. What matters is the structure of the information linking them. Space-time itself struggles to account for this. Information does not seem to live inside space. Space seems to emerge from patterns of information. This flips the usual hierarchy. Instead of particles existing in space and time may exist because of how information is organized. This idea appears again in modern theories. In some approaches to quantum gravity, space-time geometry emerges from entanglement. Change the pattern of information, and the shape of space changes with it. Distance becomes a measure of informational separation, not physical separation. Nearness is not about meters. It is about correlation. If this is true, then matter is not the substrate of reality. It is an expression, a stable pattern of information that persists long enough to be experienced as a thing. You are not made of stuff. You are made of processes, of information maintaining itself against noise. Your body is a temporary solution to the problem of persistence. Atoms flow through you. Energy flows through you. What remains is the pattern. Identity is informational continuity, not material continuity. This is not a metaphor. You replace most of your atoms over time. You do not replace your structure all at once. The structure is what you recognize as yourself. The same applies to the universe. Galaxies form, merge, dissolve. Particles appear and disappear. Fields fluctuate. What persists are constraints, rules, relationships, information. This is why physics increasingly treats information as conserved, fundamental, irreducible. You cannot delete information without consequence. You can scramble it, hide it, spread it, but it leaves a trace. Reality keeps a record, even if no observer can read it. This leads to a disturbing implication. If the universe runs on information, then what you call reality is a computation, not necessarily a simulation, not a program written by someone, but a physical process that updates states according to rules. The universe computes its next state from its current one. Laws of physics become update rules. Time becomes the sequence of informational transitions. Matter becomes a display. And like any display, it is not the thing itself. It is the output of deeper processing. This does not make reality fake. It makes it layered. The interface you experience is optimized for survival, not for transparency. Your senses do not show you quarks, fields, or entanglement. They show you objects, colors, forces. That is the user interface. Beneath it, information flows in ways your intuition never evolved to track. This is why information feels abstract. It is abstract to creatures built to navigate the surface layer. But abstraction does not mean unreality. Gravity felt abstract before Einstein. Space-time felt abstract before relativity. Information now occupies that role. The more deeply physics digs, the less stuff it finds, and the more rules, constraints, and informational relationships it uncovers. Ask yourself this: if matter were fundamental, destroying matter would destroy reality. But reality survives transformations of matter. What cannot be destroyed is information. Even when systems collapse, even when stars die, even when black holes form, information is conserved in some form. The universe does not forget. It only rearranges. And that rearrangement is what you call change. This reframes existence itself. To exist is not to occupy space. It is to participate in an informational structure that persists through time. To move is not to travel through space. It is to update relationships. To interact is not to collide. It is to exchange information. And when physics finally unifies gravity and quantum mechanics, it is unlikely to do so by adding more particles or more forces. It will do so by revealing how space-time, matter, and energy emerge from information. The solid world you trust will remain. The interface will not break. Chairs will still support you. Light will still illuminate. Gravity will still curve paths. But the story you tell about why any of that happens will change. Matter will no longer sit at the bottom. Information will. And once you see that, the universe starts to look less like a collection of things and more like a coherent process. Not built out of substance, but out of structure. Not driven by force, but by constraint. Not held together by matter, but by information continuously updating itself. This is not a comforting picture. It removes the sense that reality is something you can grasp. It suggests that what feels solid is only stable because the underlying information keeps being processed in the same way. And if that processing ever changed, the display would change with it. The universe runs on information. Matter is just how that information looks from the inside. This is Veritas Labs, where truth is tested.